Hello, this is Skylar and you are watching my tutorial, one of my tutorials, on programming the LEGO Mindstorms NXT using RobotC. Quick update, I switched from RobotC 2.02 to the 3.0 versions of 3. Whatever it is, and that's just because my free trial for 2.02 ran out and RobotC was nice enough to offer a trial for the 3.0 series that doesn't conflict. Music's by Unite the Skies, used to be Discord, changed his name, and still SoundCloud./Discord. Let's get to work. Today, we are making a rudimentary remote control of the LEGO Mindstorms NXT, so like Bluetooth control, remote control. And you can take this and run with it, and you can do all kinds of stuff. I just want to show you the basics of what it takes to do it. So start a new program, and I'll save my program as, I'll save it as Master A, and so that's the master program, and I'll start another program, and I'll save that one as Slave A, and so we got the master program, we got the slave program, and we kind of need to build them both. So, master program, first part, this is just review because we need all the stuff that we had in the last tutorial. So, first thing, ubyte, outgoing, and this is in the master, by the way, outgoing message, there we go, outgoing message equals, square bracket, there we go, equals, and this is basic array definition for C++, basically, outgoing message is an array of 2 ubytes, and a ubyte is a positive integer from 0 to 255, and the initial values are 0 and 0. This is the array of bytes that's going to be our message. That's what we're going to send. Inside task main, we want to send stuff over and over again, so not just once. So we're going to have some kind of a loop, and in this case we're going to have a while loop because it's the one that fits the job. While true, again, that is shorthand for while true equals true. And so true is always going to be true. So that's just going to run until we close out of the program. The keyword, the key function in the whole program is fit F1, and you go to search, you go to Bluetooth functions, maximize this. You can go to CCMD, right to Bluetooth, and this is, you can read up all about it right here, but this is what we're doing. And so we have CCMD message right to Bluetooth, and first thing that this function wants is an array of values, and that's what it's going to send. So we're going to say outgoing message, and it's going to send everything in there. The next thing it wants is the length in bytes of what we're sending it. So this is a ubyte, which is fine, and it wants this too, and so that too has to be right there. Like whatever, like if we wanted to send more stuff like 4, then we could send those things, and we'll change those zeros later. This 2 right here has to be changed to a 4, but since we only want to send 2 things right now, we'll keep it simple. Okay, so and then after that, we want the mailbox, because we can send it to different buffers or different storage facilities in the registers in the receiving end. So we'll just use mailbox 1. We got 2 more things. Before we do that, I got a little bit ahead of myself. We want BT connect, and that automatically connects a device to a channel. And so there's 3 channels. You can do 1, 2, or 3. And I'll just do 2. Well, yeah, 2. And this 2 has nothing to do with that 2. It doesn't. Okay. And then it needs the device name. And so my device name, like the name of my NXT, it is slave. And so whatever it happens to be on yours, that's what you want to do. Or rename your NXT and use that one. And so that will automatically connect the devices. Alright, so there's that. Last thing for this basic demo, we need a... Wait 1 MSec. And this will, I'll explain that in just a little bit. We want the, well, I'll explain it now. We want the sender to send things slower than the then the receiver can process it. And that is because if that doesn't happen, if the master is sending stuff faster than my slave can process it, then the slave just processes as much as he can, and the rest are overflow. They're waiting in line to get processed, and the line gets longer and longer and longer, and so the program has lag after a bit because you're sending stuff so fast the slave can't process it, and so you've got a problem. And so this right here is to cooperate with what I'm going to write over here when we get there. Okay, so we need a ubyte, and this will hold the incoming message, and it needs to be the exact size and type meaning ubyte, needs to be the exact same type and size as outgoing message. An outgoing message, that's just, you know, a name. It's not, whoop, what did I do there? Outgoing message is not a, is not special, it's just an array name. And that's not, you don't have to call it incoming message if you don't want to. You could call it, you know, whatever rarity or whatever you wanted to. Alright, so back to here. Task main. Same as the master program, we need a while loop. So while true. These programs are very symmetrical, and I kind of like writing them because they're nice. We don't need the BT connect, and that is because the slave connects to the master, and they're connected. The slave doesn't need to connect back or anything, especially not in this case. So we got the task main, we got the while true loop. There is another function. Instead of CCMD message write to Bluetooth, we have CCMD message read. And instead of passing outgoing message to send data, we're going to use incoming message, and this function will write to incoming message. Then we need the length of what we're going to receive, and then the mailbox. And here's the thing. Incoming message needs to be the length of incoming message it's specified right here. So like, this number needs to be the same as this number, which should be the same as however many things there are here. Like, that is 3 things, that's 2 things. That 2 is the same as this. Those 3 things need to be the same as that right there, and that right there. So, like, these values could be different, but there needs to be the same number of values as this number, this number, this number, that number, and right there. And so that has to be consistent. Because if this was a 4, this means that it's going to wait until 4 bytes are received. But if you're only sending 2 at a time, that creates some problems. And yeah, so just keep all the numbers the same, and you won't have to deal with that problem. Next thing, we have the wait when MSEC, and this time, this number, 2, we'll make that like 3. This number needs to be smaller than this number, and that's because, going back to the buffer thing, this needs to wait less time before it reads another message, or at least looks to see if one's there. It needs to wait less time than this takes to send a message. And so that is why we're doing what we're doing. In addition to that, these programs, they compile. Oh, whoop. Master gets saved as a master, yeah. And slave gets, I don't know why this thing is asking me that. But yeah, these compile. But they don't really do anything that we can see, they just receive messages and they're all happy. So I'm going to display the messages. NXT display string, and first thing's line number. Second thing's the text content. So we'll just say %d. %d is short for display the next thing that I'm going to give you as an integer as letters, like, well, as like textual numbers, like 0, 1, 2, 3, 4. Indexing arrays always start at 0, and you can Google that if you want more information. But there's a lot of good stuff about syntax. That's what I don't need to compete with that. I just want to show you about RobotC stuff. So that will display the messages that are displayed, or that are received, and then we'll erase the display so that more stuff can be displayed on it. Okay, so downloading the master program. I've got two NXTs here. If you have not paired your bricks together, like you've not done anything with Bluetooth at all, go to my last tutorial because it's helpful and you need it to do what I'm about to show you. I mean, you need it for Bluetooth, period. Okay, so my master's on. I'll download the code, and it says, yeah, it's a different NXT. Okay, I'll go to the slave, disconnect USB from my master, connect USB to my slave, hit F5. This says it's a different NXT, and that's alright. Okay, so programs have been downloaded to both. I'll now start my camera so you can see what's going on. So, I've got, let's see if, I've got two bricks. So in here, this is master, and you can see with that little B and that little less than, that is telling me that the Bluetooth is on, but this is not connected to any other device. I'm going to go to master A, because that's the program we're using, and I'll run it, and so it's running. This is my slave device, that little beep you heard. Now the B has the Bluetooth symbol, and then the less than is now less than greater than, or just a complete diamond, which means that this is working. Go to my files, software files, slave A, run, and oh, whoops. So this is working properly, very properly, but the master program, it's sending 0, I mean, as a value, and this is receiving, you know, whatever. I need to change this to different numbers so that we can see what's going on. And download the program to the master, and this says, yeah, I know what. Okay, back to the camera. So I'll run the master. Okay. Run the slave. And hey, what do you know? 90 and 0. Is that what I sent it? Let's find out. Oh, what do you know? I sent it 90 and 256. But just to illustrate my point, I actually sent 256 on purpose. 255 is the biggest number, the biggest value that a U-byte can hold. And it's kind of like saying if you've got if you had 2 spaces to hold a decimal number, you know, 0 to 99. If I tell you to hold 100, you only get the last 2 digits, which means 00. And so 256 in binary, that is like the next, that's like a 100 in decimal. And so 256, the last digits are zeros, and so we're actually sending 0. Alright, so now we can actually get down to business, if I had something to sell. The remote control. So, on the, what I have here is, I have NXT, and I've got two motors, and these motors are cool because they have motor encoders built in. And what I can do is I can measure the rotation of this motor, and so these are going to be speed controls for my right and left side. So if I want my my right motor on my slave to go forward, I want to do that. I mean, that's what I want to be able to do to make the thing go forward. So this would be like going forward, this going backwards, this would be like turning one way, or turning another way, or turning really extreme. That's what I want to get, and I'll show you how to do that. What? No. Alright, so we have that. Let's start with the master. So there is a cool thing, F1 menu. This is, I'd say this is like one of the most useful things RobotC has, is a working help menu. If you go to encoder, type that in, and you can get to a whole bunch of different things, and the most useful thing I think in this thing is N motor encoder. that keyword is sort of like motor C equals 0, except this is, you can reset these, you can find out what they are, and that's what we're going to use. If we want, we can say outgoing message 0 equals n motor encoder, and then square brackets, and then the motor we want, and then semicolon, and we're done. Outgoing message 1 equals n motor encoder, motor C, and we're done. Well, not exactly. I did do this beforehand, and so I know that the way this is set up, this is backwards. So I had a negative sign so that this works. And this is a real appropriate time to bring up. So the limitations of sending messages through a byte is annoying at this point. A U-byte can only store a value from 0 to 255, and we can have, if we want to send negative numbers, which we do, I mean, we want negative rotations, right? I mean, if we didn't have negative rotations, then we couldn't go backwards, or in this case, forwards. And so, how do we deal with that? Well, in this case, motor controllers, or motor encoders are really easy, because initially, at the end result, we want to, on the slave program, we want to say motor A equals a number between negative 100 and positive 100. And so that range of values is smaller than the range of values between 0 and 255. And so we can do this thing called a shift, where 128, if I send 128, that really means stop the motors. Like, if motor encoder, motor C, if that ends up being 0, that means the motor has not turned, motor C has not turned at all. And so that's when I want the motor to, the slave motor to stop. And so 0 plus 128, we're actually sending 128. When we're receiving this, we're going to say, and motor C, motor C equals, some number. We're going to shift it back down. So if this is 0, adding 128 means send 128. But we want to bring this back down to 0. And so we're going to say incoming message minus 128. And so, simple, right? Just takes a little bit of thought. And like that. And this, I'll set this back to 0 so we don't have any shenanigans going on. That is basically all that we're doing differently. That's what it takes to write a remote control. Except for one thing. If I don't connect these instantaneously at the same time, start the master program and start the slave program, it'll try to read the message, and if it can't read the message, then it'll just it'll just give up and go to the next thing. And so incoming message is going to initially be 00, and if CMD message read if it doesn't have anything to rewrite incoming message to, then it's going to stay 0, which means by the time it gets down to the motor values, incoming message will be 0, and it'll be setting the motors to negative 128. And so I'm going to set the initial values of incoming message to 128, 128, which is just the stop command. And so that will help. It'll save you a bit of headaches. And so I will demonstrate by downloading the code, and then we'll see it. So right now I'm connected to the master. Download the master program. Reconnect the USB to the slave, and download the slave program. Alright, so back to the camera, and full screen this on here. Here we go. I'll run the program. So the master is running, and it's already connected from the previous time, so it's not going to beep this time. I mean, it's already working like that. And so that's just going to go down here. And so here, I'll run the slave program, and right now it says I got some values. And hopefully, when we move this, the numbers, hopefully they'll change. So you can see here, they're different. So I'm going to go ahead and plug the motors in so that, well actually no, I'm going to restart this process because it'll start going right away. I'm going to tilt the camera around so you can see somewhat of a drivable area, and I'll take the Mindstorms NXT, plug in my motors to A and C, and put that on the ground, or floor, not dirt yet, and then I got this, and then, oh, whoop, I didn't run it below. Okay, I'll run this, and now I'll run this. So if I want to control it, I can. Alright, so that's basically the, basically it's the basics of remote control NXT. And there's a lot more you can improve upon this, and next time I will explain how to send a bigger number than 0 to 255, because that's kind of limiting. If you want sensor feedback from your robot, or all kinds of other stuff, sending numbers bigger than 0 to 255, sending larger values, that's kind of imperative. So yeah, if you have any questions, or suggestions, or topics you want me to cover, or ways I can teach better, please let me know. And yeah, have a good Tuesday or whatever, and